Hey, friends. Number four, this is trying to help you see whether, like, the difference in the growth pattern between an exponential function, which 3 to the nth power is an example of an exponential function, and a quadratic function, and 5n squared is an example of a quadratic function. So determine whether 5n squared or 3 to the nth power will have the greater value when n equals 1, n equals 3, n equals 5. Like, the most straightforward way you could do this is to just like do the calculations, because it's not that many calculations, and you'll see that 5 n squared is greater, has a greater value when n equals 1 and 3, but when n equals 5, it flips and 3 to the nth power is bigger. Okay, so this is the most straightforward way you could think about it. If you wanted to, I made a table, and I actually used some functions in the Excel spreadsheet. So like for this one, 5x squared, it's 5 times the value in A2, which was 1. So this is like 5 times 1 times 1. The next value is 5 times the value in cell A3, which is 2. So this is 5 times 2 times 2, blah, 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 all the way down. And when you're doing this on an Excel spreadsheet, all you have to do is do the first one and then copy it down. There's a Control D. It's a function. If anybody wants to know how to do this, I can totally show you. So this is similar: 3 to the power of 1. So 3 to the power of the value that's in cell 2. 3 to the power of the value that's in cell 3. So this is 3 squared. 3 to the power of the value that's in cell 4, A4, which would be 3 to the third power. Anyway, keep going down. The point here, though, is that you can see, looking at these numbers, that between 1 and 3, 3 to the x power is bigger. But after 4, sorry, for 1, 2, and 3, 5x squared is bigger. The green is bigger. But then after 4, 3 to the x is bigger, and it actually gets to be a lot bigger. So 500 compared to 59,049, like, that's a big difference. So you could think about it using a table. You could also, Desmos. You could also look at it on a graph. So 5x squared is going to look like this. 3 to the x power is going to look like this. So you can see that there's a little bit of weirdness happening kind of down around here. Oh, that's not the weirdness. This is the part where x squared is, or the 5x squared is bigger. But if we go in, this is where the weirdness is. It's because exponents are weird. Exponential functions are weird. But you can see that the red line, so the 5x squared is greater than the blue line, 3 to the x, until right about here. So right about 3.9 at 4. Yeah, so right about 3.9. And then after that, it gets like crazy how much bigger that the exponential function is. It grows a lot faster. Cool. And I messed up my window. Y'all, I don't care. That is the basic shape of an exponential function. Let's make that, can I make that wider? Yeah, it kind of has a, like, it's really, really flat. Gets really, really close. Yeah, it's really, really flat, and then it grows really fast all of a sudden once it starts growing. Okay, I'll stop talking. Have a good day.